Dear learners, welcome back to NPTEL online certification course on novel drug delivery systems. I am Dr. Satish Devanapelli, Assistant Professor at Department of Pharmaceutical Sciences and Technology, Institute of Chemical Technology, Mumbai. So, we are discussing gastroretentive drug delivery systems. In that, we started in our first class on the introduction to gastroretentive drug delivery systems. And in our second class, we have discussed on the types of gastroretentive drug delivery systems. In that, we have discussed the low density or floating gastroretentive drug delivery systems. In that, we have discussed two topics, that is non-effervescent and effervescent gastroretentive drug delivery systems. And after that, we have discussed on the high density gastroretentive drug delivery systems, and further we discussed on the expandable gastroretentive drug delivery systems. And here also we have seen two different topics. One is on the swellable gastroretentive drug delivery systems, and the another one is we have seen the expandable. In that we have seen the unfolded expandable systems. So, today we are going to discuss on the remaining types, that is super porous hydrogels and the mucoadhesive or bioadhesive gastroretentive drug delivery systems, raft-forming magnetic based gastroretentive drug delivery systems, ion exchange resin based gastroretentive drug delivery systems. In that, the first topic, that is the fourth topic, it is super porous hydrogel systems. The name itself speaks about that. It has a porous in nature, which contains the pore size of 10 nanometer to 100 micrometers, and there are the materials which contains more than the 100 micrometers of the pore size, which will help in the taking of the water into their systems, and which are nothing but the polymers which will swells very high compared with the conventional polymers which we use for the conventional hydrogels. These polymers are, the example is sodium alginate and the cross caramelose sodium. We need to cross link such polymers with the other types of the excipients, which will help in the loading of the high amount of the water in their structures. So, that is why which are called as super porous hydrogel systems, which are undergo the swelling, and that rate is very high, that is more than 100 times compared with the conventional hydrogels, and these are enough to maintain the mechanical strength to withstand the pressure by the gastric contraction which happened in the GIT, and ultimately this will help in the increasing of the gastric residence time in the body. And you can see here with the pictorial representation, here is a drug and it is a highly swellable polymers that we need to make into one unit dosage form. After administration, it will undergo swelling. Now, you can see the area of the final dosage form after administration, the size is increasing because it is undergo swelling, and that will help to remain in the GIT conditions, and it undergo rapid water uptake by the capillary mechanism, and it will undergo the expansion, and further it will retain once the drug is released, and these materials undergo the degradation, and it will undergo the shrinkage, then the material will go out from the stomach. So, which are called as superporous hydrogel systems. So, this is also one of the mechanisms we can use in the gastroretentive drug delivery systems for the improvement of the conventional oral drugs. And the another topic, that is the mucoadhesive or bioadhesive gastroretentive drug delivery systems, and we know the mechanism of mucoadhesive. Now, you can see in the pictorial representation. So, this molecule specifically attached with the biological systems, whereas in conventional your medicine will come and will leave from the desired site, but whereas when you have narrow therapeutic index, such cases your dosage form need to retain and that need to adhere at that biological membrane. So, to get that we need to convert formulations into the mucoadhesive or bioadhesive systems. Now, which will adhere to the mucus. Now, we can see that mechanism in this figure also. So, here is the mucous membrane. After administration, it undergo two different stages. One is the contact stage, another one is the consolidation stage. Whereas in contact stage, it will, after administration, it will go and adhere to the your mucous membrane. This is a mucous layer, and you can see this, it is only contacting. Now, consolidation stage is very important for the mucoadhesive system, and it depends on various factors, right. So, that we will discuss in our upcoming lectures on the mucoadhesive drug delivery systems. Now, in the consolidation, what happen once the medicine or dose form is contact. So, now the water molecule of this mucus will enter into this, that is undergoes the dehydration stage, and further this molecule will taken up into the mucous membrane. So, that is diffusion. So, there you will see the entanglement of the mucin and with your polymeric material or the dosage form. So, that is called as consolidation, is nothing but uniting of two things at one process, which is called as consolidation. So, here yes, this will work on various mechanisms that we will see in next slides. So, here is the few examples: electrostatic interaction by the hydrogen bonding and the van der Waals mechanism, which help in the bioadhesive. These are the polymers, we can use it as a natural polymers, that is nothing but chitosan and the pectin, and synthetic polymers carbopol, HPMC and polycarbophyll. This will help as an mucoadhesive polymers in GRDDS. Now, these are the 5 different types of the theories people have predicted, and that will help in the mucoadhesion. So, first one is wettability. By seeing that, you will understand these polymers should have wetting properties, and that will help in the bioadhesive mechanisms. So, these polymers will penetrate and develop intimate contact with the mucous layer, that your polymer should be hydrophilic in nature. With this, it will help for the mucoadhesion. Now, the diffusion already I have explained in the stages. So, here what happened, this is another mechanism, this will help in the diffusing of your polymeric material and interacting with the mucin, and that will form the physical entanglement of the mucin. So, and yes, the flexible polymer chains are very required, and it can be influenced by the molecular weight, cross linking density, chain flexibility and expansion capacity of the both networks. So, all these topics we are going to cover in the mucoadhesive drug delivery system separately, and the adsorption mechanism. So, that will also involve various types of the mechanisms: ionic, covalent and metallic and van der Waals and other types of the mechanisms will help in the bioadhesion. Electronic, now it is very simple. we have a mucin, and mucin has various types of the functionalities in that molecule, especially the glycoprotein. So, one best example is it contains the sialic acid, which shows the negative charge which is exist in the surface of the mucin. But when you want to work out with the electrostatic interaction, you need to develop various types of the systems which should have a positive charge on their surface. So, especially chitosan is the best example that will interact with the sialic acid of the mucin and with the NH2 group in the chitosan. So, this will help in the electrostatic interaction. So, that may happen with the electrostatic interaction. And the last one is the fracture. This is some type of the mechanical forces required to generate such type of the mechanism. So, it will apply on, you need to provide some pressure, that means we need to put some pressure on the mucus, and then we will see what is the detachment force is required to separate your dosage form from the mucin. So, that is also another mechanism. Total 5 mechanisms: wettability mechanism, diffusion, adsorption, electrostatic, and the fracture mechanism. So, these 5 mechanisms will help in various types of the mucoadhesive gastroretentive drug delivery systems. Not only this system we use in the only oral, we will also use in other cases also, like nasal delivery, as in even we will use in the ocular delivery, other type of rectal vaginal delivery system also we use this mucoadhesive polymers as carriers. So, the raft forming, now the name, by seeing that you will understand, raft is nothing but forming a gel like structure and that will float on the surface of the gastric fluid. You can see in the picture. So, there is a raft forming, and raft is nothing but like a boat which will float on the water. So, this also, these systems will form a gel after interacting with the gastric fluid, that you can read here. Upon contact with the gastric fluid, they form gel like floating, that is raft on the top of the stomach content. So, which is also known as cohesive gels, and which will create the raft forming in the stomach. So, especially this will be prepared for the gastroesophageal reflex treatment. So, here we can use various types of the antacid drugs to deliver aluminum hydroxide and the calcium carbonate and the simethicone. With this we can expect we can increase the gastroretentive time. And you can see here we can use various types of the alginates, gel and gums, which will help in the formation of the cohesive gels with the gastric acid and other type of the ions which are present in the body. So, with this we can make raft forming, which will also the help in the designing of the gastroretentive drug delivery systems. So, seventh one, we are going to discuss on the magnetic gastroretentive drug delivery systems. So, here the most of the cases, various types of the gastroretenting, we are dealing with the various types of the excipient, they have specialized properties. So, similarly in magnetic also, here we use some quantity of the magnet, especially in case of the iron oxide type of the nanoparticles and the materials which have the magnetic properties. Such type of the materials we will incorporate into our dosage forms. So, now here you can see here in the picture. So, this is the dosage form and which contains the drug and the internal magnet and then polymers. So, we will make a formulation, that is with the API and the excipient and then internal magnetic material, and then we will make a dosage form. After administration, it will enter into the stomach, then we put some time of the external magnet, so that your material or your dosage form will come to the particular site for the localized delivery, where we keep our magnet as external magnet on the stomach, and it will retain for longer time, and that will help in the targeted dosage form, and also it will extend the retention time. So, we need to provide the external magnet, then your dosage form will come and stay at that particular localized site, and then it will show the release. If you keep it for 3 to 4 hours, then your dosage form also will retain, because you have provided the magnet in the formulation, and when you apply external magnet, that will come and stay at that particular place. So, with that also we can extend the gastro retention time. So, here we use various polymers, especially we need to incorporate with the various magnetic materials, which are ferrite or other magnetic materials. And external magnet, we can use it as a belt or some of the patches, so that we can do our daily activities, and but your dosage form will come in and will stay at that particular site where you applied the external magnet, then it will slowly release the formulation at that particular site. So, this is also one of the innovation in the gastroretentive drug delivery systems, but we need to focus on the what is the minimum limit of the internal magnet, because these iron oxides also sometimes will induce the toxicity in the body. So, that we need to focus. And the eighth one, that is the ion exchange resin based drug delivery systems. This we have specifically discussed in our control release drug delivery formulations. So, this ion exchange resins we use to utilize various types of the acidic and the basic functional groups, which are help in the drug release. In ion exchange resin based drug delivery systems, we use water insoluble synthetic polymers, and which contains acidic basic functional groups in a repeating pattern to conjugate or to interlink with various types of the drugs, which are in weak acidic and weak basic in nature, so that we can make any complexation of these drugs, which will help in the gastroretentive drug delivery systems. So, here you can see in the example, as we discussed in our control release formulations, here there are the cationic resins are there and the anionic resins are there, and we have cationic drugs, we have anionic drugs. So, here if you use some X resin with some drug molecule which has an X anionic properties, first we need to make a complexation, right. After that we need to give it to the as an oral formulation, right. So, before the drug release, so they are bound with each other. When you have after administration, these gastric ions will help for the replacement of your ion exchange resin molecules, then your drug will release in the absorption site. So, with this we can make a controlled release of the oral drugs. So, with this also we can expect the high gastric residence time. So, those drugs are sensitive to the particular pH, and those drugs are which are sensitive to the particular pH conditions, and such cases we can use such ion exchange resins. So, that will release slowly in the GIT conditions. Yes, the condition is that these gastric ions will replace your drug and then your drug will release and come in contact for longer time. So, this is also one of the best mechanism as in a gastroretentive drug delivery systems. So, we can use various types of the ion exchange resins. You can see here, so the polymer based or the ion exchange resin based systems, with that also we can enhance the gastroretentive drug delivery systems. So, this is the summary of the all types of mechanisms which we have learned on the various types. The first is low density or floating systems. This will works on the buoyancy, that is very important. With this we can make various pellets and tablets. The density should be lower than the stomach fluid. And also we have learned that second topic, that is the high density. Here we use the various types of the materials like barium sulphate, titanium dioxide and other materials which help in the sinking of the dosage form, that will also help in the high retention time. And the third one, in the expandable we have seen the swellable and also unfolding systems, that will also help in the as in a GRDDS system. And fourth one, we have seen the bioadhesive. It has various functions and here you can see these are the various types of the theories and it will help for the GRDDS system. And the fifth one is raft-forming, which will form the gel layer and that will also help in the floating. And the sixth one, super porous hydrogel systems, and they have swellabilities maximum compared with the conventional polymers, and this will work by the capillary mechanism that will help in the retaining of the in the stomach. And the seventh one is magnetic. Here we use some magnet that will mix and then we will position our magnet on the stomach, so it will retain for longer time. And also we have seen ion exchange resins that we need to complex with your drugs and that will deliver. Yes, you can use even floating system like combination or multiple type of mechanisms like floating and other bioadhesive systems. So, that will help in the gastroretentive drug delivery systems. So far we have discussed on the various types of the gastroretentive drug delivery systems. In our upcoming classes, we are going to discuss on the some of the technologies, some recent advancements which are involved in the gastroretentive drug delivery systems. So, with this we are going to stop today's lecture. Thank you so much.